This demonstration of Design++ shows how we combine engineering, configuration, geometry, and change management to create a custom-generated solution for the roof and frame design of a simple building. We begin by opening Design++. Next, we open a demonstration project that contains some basic knowledge about metal buildings and structures. Then we load the libraries of the roof and frame objects that contain the knowledge and rules for this application. We close the Design++ development environment so that we can focus on the demonstration user interface. First, we need to create a new model. For Design++, this means opening a CAD application to display the three-dimensional geometry. For this demonstration, we will use Tekla Structures. For the demonstration application, we begin the modeling by inputting building dimensions and choosing some basic structural options. From this input, Design++ generates a building model, and from that building model, Design++ produces geometry in Tekla. The model generated has roof panels, purlins supporting the panels, and a set of frames supporting the purlins. All of the components are native Tekla components, selected, placed, and configured by Design++. The Tekla model is the result of Design++ driving Tekla, just like the end user would. For frames, the tapered frame commoner from the Tekla catalog library is used. Users can examine the components' properties in Tekla as if they had created them manually. The roof panels are Tekla panels. Tekla steel beams are used for the purlins. Let's see what happens when changes are made to the input parameters. When the end wall is skewed, notice how only the purlins, the end frame, and the affected roof panels are changed. For the next change, the building length is increased and the skew of the end wall is removed. Notice how the interior frames and purlins disappear. However, Design++ determined that one of the end frames in the roof panels did not have to change, so they remained. Even with this simple model, we can go into great detail. For example, we can turn on the connection display. This is a bigger change, so most of the geometry has to update. We can zoom in close to take a look at a purlin connection and see that it is a standard Tekla connection clip. For connecting roof panels, Tekla bolts are used. Next, the purlin connection type is changed from simple to continuous. This is a significant change requiring a complete redesign of the connection to handle the overlapping purlins. We can rotate the view to see what the new splice connection looks like on the inside with the attached clips. From the complete model, we can report on all of the physical components in the model using the integrated report writer in Design++. Furthermore, since all the geometry is in Tekla, we can also use Tekla's reporting capabilities. This is an example of a typical design automation application using Design++. With minimal input, Design++ allows users to generate detailed material quantities and produce very valuable visualizations that help the user make more effective decisions and, as a result, better designs.